Hello everyone, and welcome to episode 5 of Harmonia plugin tutorials. In this episode, we'll go over the directional light and the exponential height fog. Let's start with the directional light. One of the main reasons this plugin exists is about to explain itself. In the native Unreal setup, as I covered in the introduction, if you have an HDRI and then you enable a directional light, you end up with double shadows, unless you manually match the direction of your directional light to the direction of the sun in your HDRI. In our system, we've designed a solution that removes the need to match those two at all. As you can see, right now we only have one shadow, and it looks as though the directional light is simply sitting at the same angle as the HDRI. But watch what happens when I rotate the directional light. I still have a single shadow, no double shadows, and my HDRI is still at exactly the same angle it was before. And it works the other way around as well. I can rotate my HDRI without ever worrying about double shadows. So this effectively unlocks something that was missing in Unreal, and it lets artists reach whatever lighting they want without ever having to think about double shadows in their scene. With that said, let's take a look at the settings we have for the directional light. Most of these are the same controls that the directional light actor inside Unreal already offers, so there's nothing extraordinary here. Directional light intensity controls the intensity of the light, and the temperature controls its temperature. The light source angle controls how big your light source is, which is what gives you control over the softness of your shadows. Then we have two values to control the angle of the sun. The pitch controls how high the sun sits in your sky, so this is what you use to create the different hours of the day, and the yaw rotates your directional light around the z-axis. Easy to understand and easy to follow. The specular scale controls whether the directional light is visible in your reflections or not. If I put it at 0, you can see that it's not visible in the reflections anymore, and if I bring it back to 1, we can see it again. Then the directional indirect intensity, as the name suggests, controls the amount of indirect bounce that the directional light creates inside your scene, which matters most for interior spaces. And with that, we come to the end of the directional light. As you can see, it's very easy and very intuitive to use. It doesn't matter which HDRI you're using for your cubemap. Regardless of the map, these features work as expected. Everything happens automatically in the background, and you will never have double shadows in your scenes. The last switch in this section is Enable Exponential Height Fog, and that takes us to the second half of this episode. The exponential height fog here is Unreal's default fog actor. Nothing about it is specially designed in this plugin. The only reason we included it was convenience. Instead of adding your fog actor manually and then controlling it separately, we decided to bring it in here as well. And by default, we enable it as volumetric fog so that it works with the path tracer. Fog density, fog height falloff, scattering distribution, fog scattering color, and view distance are all exactly as their names suggest. They are the standard parameters of Unreal's fog actor. The one to be aware of is view distance start. This value, unfortunately, does not work with the path tracer. That is not a limitation of Harmonia, it's a limitation of Unreal, and as of now there is no way to make it work with Unreal Engine's path tracer. If you switch over to Lumen, this value works exactly as expected and creates the distance at which the fog starts. In the path tracer, for the time being, it doesn't. We still decided to keep it because it does have a function in Lumen, and if the situation changes in the future, and Unreal does support a start value in the path tracer, the feature is already here and waiting for you. And with that, we come to the conclusion of this episode. In the next one, we'll head over to the sun-sky system and give you a quick explanation of how that system works. Thank you for watching, and see you in the next episode.